Okay, hello go-getters. I just hope guys you are doing good. So here I just want to show you when they say calculate the area of the shaded part. So they want you to determine this space actually. When they talk about area, they talk about the space of a shape. So they want you to determine the space. In order for you to know the space, you should know that here you are given this side. Do you see this side? And this side, it's being shared by two shapes, which is it's being shared by the triangle and also by the what? By the square. Meaning here it's x and here it's also x, the distance. Do you see? Then from here we got this x and the height now is that one. X. So these two sides are being shared by two shapes. Do you see? And they want you to determine the shaded part. To determine the shaded part here, first you must know the area of this thing and also the area of that thing. So let's go ahead. So to get the area of a square, it is area of a square. Let me just write it down. Square. It's equal to length multiplied by length, which is our length there, it's only x, which is this thing, it's x squared. Area of a square. This one, it is the area of a square. Do you see my study? This one, it is the area of a square. Then to get the area of a what? Of a rectangle, we use area of a rectangle. It's equal to half base multiplied by height. Then our base here is this one. This one is the base. And the height is that one. Do you see the height? And this height is the same as that height. Do you see? Yeah. So meaning our height there it's x. So when I substitute there, I will just say x, which is that one. And I substitute my height, which is also x. So now what I will get there, it's 0.5 x squared, which is the area of a what? Of a triangle. Yeah, this one, it is the area for triangle. So check something, guys. So now you know both of the areas for a squared and the triangle. So I want you to notice this thing is in this one is the what is the square. If I'm taking out all this piece here, the one which is a what? The one which is a rectangle, a triangle. Yeah. If I'm taking out this triangle from this square, if I'm taking out all this part from the square, I will only left with this one. Do you see that one? All that one. I'll be only left with all that one. Yeah. If I'm taking out the triangle from the square, I'll be left with the area of the shaded part. So meaning now what I will do from here, I will just say the area of the shaded part is equal to area of a square taking out the area of a what? Of a triangle. Yeah, when I'm taking out, I minus, guys. Yeah, taking out, I minus triangle. So meaning now the square there is just, and the triangle 0.5 x2. So check something, guys. These two things are just like term because they have same base and same exponent. Meaning now I can press this thing from my calculator. Remember, guys, here there is invisible one. Meaning when I press this thing on calculator, I'll just press invisible one and say minus 0.5, which is, this is the answer that I got, which is 0.5. Meaning now when I collect my like term, I'll have 0.5, then the base and the exponent remain the same because I'm collecting like term. Meaning that this one, it is the area of the shaded shaded part, this one. This one, it is the area of the shaded part. Yeah. So this is how we identify the area of the shaded part, guys. So let me just do another one. So here's another question for calculating the area of the shaded part. So like check something to get the area of this shaded part. You should know here I got two shapes, which is I got a big circle and I got the small circle. And those two shapes are being shared, like are sharing this height actually. Yeah, they are sharing this height. So check something, guys. So here I got some two circles. I got two circles there, meaning I got two shapes. A big circle. This one is the one which is a big circle. And this one I'll just say it is a small circle. So this one I'll just represent as in its SC. And this one I'll just say it's BC. Yeah. So meaning okay. Yeah. So now I want you to consider something. So this radius, it is for what? For a small circle. You see right? This radius. And the big radius, it is the radius of the big circle. So now when I calculate the area of this thing, I'll just say area is equal to pi r squared, which is this one is for what? A big circle. This one, it is a big circle. So but my r there is this one. This one is my radius, guys. This one, it is the radius, is that one. Yeah. So meaning now when I substitute, I'll just substitute the big R, A, B, C. Yeah. So which is this thing is just pi C R squared. You see my study? Yeah. So now if I want to calculate area of a small circle, is just SC, which is area and squared. So guys, this one, it is the radius, this one, which is also here the radius. It's been represented by small r. No need for me to just substitute the radius in a radius. Something like do this thing. I'm substituting radius. No need to, because still I will end up here. Do you see? Yeah. So there was no need to just substitute a radius. Yeah. So what I want you guys to notice is that here I know these two areas for a big circle and a small circle. And now from a big circle, if I'm taking this thing, if I'm taking out all the small circle from a big circle, I will be only left with all this part. Do you see all the other part there? Yeah, all this part, which this part will be the shaded part. Meaning now to get the area of the shaded part, I must take out the small circle from a big circle. So this thing will just become like, to get the area of the shaded part is equal to a big circle minus by a small circle. Do you see my study? Yeah. So when I substitute my big circle, now I know the area of a big circle, it's pi r squared. Yeah. And also here it's pi r squared. Do you see? Yeah, I just substitute this thing here and that one there. So now to simplify this thing, guys, here you cannot say these two things are the like term. This one, they are not like term. Because this one, it has a small r, while this one, it is a big R. Remember, guys, like a base must be the same. These bases are not the same. This one, it's a big R, and this one, it's a small r. And their exponent, yeah, they are the same, but the base are not the same. Do you see? So these two things, you cannot say they are like term. But here you can take the common factor which is the common factor there. It's only pi, the common factor. And if I divide there, I will only left with this r. And if I divide there, I will only left with small r here, which is the area of a shaded part. Area of a shaded part. Here I just take the common factor. And please be aware, guys, even this thing I can still factorize it, this one, in different of two squares. And then it will become like the area of a shaded part, it's pi, which is r big R and r plus or minus. I just hope, guys, you can see this thing. R plus or minus over pi. This one is the area of this thing. Do you see? Yeah. So I just hope, guys, you did understand this question.